Welcome to the video series for Chapter 10. I'm actually going to take this a little bit out of order and do the summary first. The summary for this chapter is a little bit more involved, shall we say, than the summary for a lot of our other chapters. And then I'm going to take Section 1 and then Section 2. Those are probably going to both be multiple videos apiece because we've got a lot to cover. Now, of course, if you, a lot of this, what we're going to cover in this chapter, because this is about a chapter about tuning and troubleshooting, a lot of it should at least be somewhat familiar to you already. All of the practically all of the commands I'm going to introduce, you've used before. The only one that we really haven't used yet are the priority and preemption commands that we use for DR, BDR election. Of course, if you've done the first lab or watched that demo series, those two demo videos, you've already got a sense of where this is going. So let's talk about what OSPF is and how we tune it and troubleshoot it. There are some flow charts in the troubleshooting section and some important bits of new terminology in the first part in the tuning section. Pay close attention to those. When you're troubleshooting this for one of your labs or out in the real world, you need to be able to work through that through that flow chart. Whether you've got it on paper or you've got it in your brain, you need to be able to work through that process. What is working, what is not, work systematically, and so forth. So, no. We started off talking about point-to-point OSPF. That is OSPF in a set of serial connections. Then we added broadcast multi-access, which is to say Ethernet. We explored that with, we will explore that with DR and BDR elections. There are other types. Non-broadcast multi-access. When you hear non-broadcast multi-access, or NBMA, the thing we are most likely talking about is frame relay, which is a technology you'll talk about in more detail in Connecting Networks, the CCNA4 course. There's also point-to-multi-point connections. That is to say, one point, you can more or less think of this as a hub and spoke topology. So that you've got multiple branch sites talking to a core, and they may be doing their neighbor relationships all toward that hub site. Then you've got virtual links. We'll talk about that in more detail at the beginning of Section 1. These multi-access networks add some new challenges for OSPF, specifically related to neighbor relationship, neighbor adjacency, and what that means for the number of LSAs that you have to build, the number of neighbor relationships that you have to maintain. As we discussed in a previous video series, the math on that is n times n minus 1 over 2. So if you've got a small number of networks, that's not a whole lot of neighbor adjacencies to manage. With 3 routers, that's 6 neighbor adjacencies, no big deal. With 4, you get, anyway, 5 you get 10, and then it goes up from there. It gets unwieldy in a hurry. So, and because any large OSPF network is going to have a lot of routers to talk to and about, that really doesn't work. And of course, all that means lots of LSAs, link state advertisements floating through the network. That's a lot of traffic. We solved this problem by having one router in that multi-access network be the point of neighbor adjacency for all the other routers in the network. The DR others have their neighbor adjacency to the DR. The BDR has its neighbor adjacency to the DR. The DR others don't talk to the BDR at all until it becomes the DR. If the DR stops sending out its hello packets, the BDR will promote itself, it will become the DR, and everything will go. Of course, the router in the network with the highest priority becomes the DR. If you really want to make certain that a specific router becomes the DR, you give it a priority at or near 255. If you want, conversely, if you want to make sure that a router cannot become the DR, say for example, it's old and slow and placed in the wrong part of the network, give it a priority of 0, and it will always be a DR other. The default, of course, is 1 for multi-access broadcast. So I said non-broadcast multi-access, that's frame relay. Multi-access broadcast or broadcast multi-access, Ethernet. Just think about how an Ethernet network works. How hosts on the simplest possible Ethernet network, which is to say, a whole bunch of hosts tied into a hub, or a whole bunch of hosts with thin Ethernet coaxial cable tied into each other. They all kind of broadcast. They all hear each other. That's a broadcast network. But if they all have the same priority, there are other factors. The highest router ID wins, which is to mean, say, the one with the highest specifically explicitly stated router ID wins. Alternatively, the one with the highest loopback wins. Alternatively to that, the one with the highest IP address wins. And of course, because it can work on the basis of IP address, because it's not going to really look at MAC address. So because this is a layer 3 technology, the election is going to work on layer 3 terms, whereas with, say, spanning tree, those bridges in a spanning tree are going to look at MAC addresses, layer 2 information, to make their decision. So let's talk about default route propagation. So this is something we've done before with RIP, in point of fact. You set up your default route, whether it is a static default route with a IP route quad 0, and then your next hop or your exit interface, or both if it's a fully specified route. Or alternatively, if your default route is produced from another routing process, say EIGRP or BGP or whatnot, the default information originate command will still work. So there's that. You can also verify that with show IP route or show IPv6 route. The only difference there is that with show IP route, you could literally do, if you want to see if the gateway is there, you could literally do show IP route pipe include gateway, and it will just show you that gateway line. Unfortunately, you can't do that with v6 because there's no line in the v6 routing table that says gateway. And then, of course, if we want to tune our path determination, we have to think about whether what the reference bandwidth is. By default, the reference bandwidth on an OSPF router, even if it's an OSPF router which only has gigabit and 10 gigabit Ethernet links, is set to fast Ethernet speed, which really doesn't help us. So if you need your network to meaningfully discriminate between, and this is discrimination in the good sense of making a valid choice, not prejudice, you have to set that reference bandwidth. Say if every interface in your network is gigabit, and some of them are 10 or even 40 gig E, then you set your reference bandwidth to 10 gig, so that to gigabit speed. Actually, what you do is you set it to 10 gig speed, so that the fastest common, say your 10 gig lines, that's your reference speed. Those are the interfaces which will have a cost of 1. And then your gigabit lines will have a cost of 10. What you don't want to do is set it all to gigabit speed, because you still are not discriminating correctly. On the other hand, if you've got some fast Ethernet and some gigabit and nothing faster than gig, you use your gigabit speed as your reference. So go with your fastest common bandwidth. Say, for example, if you've got a whole bunch of gigabit interfaces and maybe 1 or 2 10 gig E's, maybe you can tune those 10 gig interfaces specifically or something. Okay, so the other thing we have to think about is your hello intervals and your dead timers. These must match, or neighbor adjacency will not form. Your hello interval command is IP OSPF hello interval. Your OSPF command dead interval is uses the dead interval command. The thing to note here is that your dead interval should be 4 times your hello interval. So if you tune your hello interval to be a minute instead of every 10 seconds, then your dead interval should be 240, not 40. Because of course, if you're now, and the router will probably notice if your dead interval is lower than your hello interval, and it won't let you do that. But in any case, make sure that you keep the multiplier the same. 10 and 40, 20 and 80, 30 and 120, 60 and 240, 60 and 240, etc. And we can do the same thing with OSPF. OSPF uses the same hello and dead intervals as OSPF for V3 for IPv6 uses the same hello intervals as IPv4. Now, let's talk about our troubleshooting commands. So, the fun thing is that V3 uses all the same commands as V2. Show IP protocols, show IP OSPF neighbor, show IP OSPF interface, show IP OSPF interface brief if you're on physical hardware, show IP OSPF, the route. You can even look at the database with show IP OSPF database. And you can clear your processes. If there's only one process and you do show clear IP OSPF process, it'll get it. If you have more than one process, then you only want to clear one of them, you have to specify. So we'll get back. We'll cover all of this in more detail in the rest of the video series. And thanks for watching.